Hello and welcome. Today we're going to be talking about the official MCP registry. This will be primarily for MCP client implementers and MCP server publishers. So to start with, the official MCP registry is a project from the MCP group. It's an open catalog and API for publicly available MCP servers to improve discoverability and implementation. By standardizing how servers are distributed and discovered, we're expanding their reach while making it easier for clients to get connected. So they're solving a pretty big problem, both in terms of not just how we discover MCP servers, but also how we're able to configure and install them in a way that's maybe a little more user-friendly as these become adopted more broadly. So the old way is essentially you find an MCP server somewhere on an official page in a registry of some kind or get a GitHub repo. You go to the documentation, you find a sample MCP server's JSON configuration, you copy it, you paste it into your client, you sort of fill in the placeholders and hope you haven't figured out how to configure it correctly, and you pray and you push the button. It's pretty ugly. It's not too bad considering that most of the people who do this are software engineers, but as MCP becomes more widely used, and we have people who are maybe a little bit less technical trying to use MCP servers in their agents, it's definitely not going to scale. It's not going to work. The new way we're doing it with the official registry is the model is essentially the client's going to let you search a registry via an open API, pick a server. The client's going to be able to generate custom user experience to help the user configure the server, which gives them documentation, hints, guardrails, basically everything they need to just sort of point and click and create a proper server configuration without ever even seeing that JSON. So they can just sort of point, click, and go. That's the goal. And I'm going to show you some examples of how you can sort of help make that happen. So I'll give a quick demo just to kind of demonstrate this, I think, in an easy way to make it really hit home. So we have an MCP server tool catalog that we built on top of the official MCP servers page that we update daily. And it's just a way to help you search and find those things. It's maybe a little slightly easier than scrolling through that page. But at the end of the day, you're still just sort of ending up with an MCP server JSON that you have to copy and paste. And the new way that we're doing this is that we implemented in parallel to that a similar application that sits on top of this new official registry that allows you to search and filter in similar ways, but it actually allows you to configure an MCP server through some custom generated UX driven by the configuration of the repository, and then automatically generate the MCP server config. So kind of what I showed you before. So let me just give you a quick demo of what that looks like. So this is our tool catalog page. This is an open source project. The data feeds are also available via open source for anybody to use that wants to embed them in their client. So I'll show you what the old one looked like. This is basically a tool, a server catalog that sits on top of this MCP servers page. So it takes all these servers off this page, it scrapes them all, gets all their GitHub repos, gets sample configuration out of them. So it's just sort of a slightly friendlier way of doing exactly what you do if you're using this page, which a lot of people do. And you can see things like, oh, say I only want to see officials, and I can filter to only see certain servers. And if I want to install one, I click it, and this is basically sort of all you get. You get some metadata about it, you get a link to the repository, some metadata about the repository, and then you get a sample configuration. So you can copy that configuration, paste it into your client, and some of them aren't too complicated. Like this one's pretty straightforward. You're going to copy and paste this, and you're going to stick your API key right here. A little ambiguous as to whether or not you need quotes around it. But some of these can get quite complicated. You don't know if the arguments can be repeated, if they're secrets, if they're required, what values there can be in those arguments, if there's different restrictions on that. So it's, you have to read a lot of documentation to sort of understand how to make these work in a lot of cases, which is not ideal. And I'll give you just an example of sort of how this works in the new world. If you use the registry browser, it's a very similar experience where we can filter on tags and search for things. So let's go search for a particular one. So I'm going to pick a server. So similar experience, I can see the server name, which is now this reverse DNS style name, description, version, things like that. I can see the repository like before. Now I can see that it has some packages that I can install. So I can actually install and run this thing. And it's got some metadata. So let me do that. Let's pick one of these things and say, look, I want to configure this particular package of the server. And instead of seeing a big ugly bunch of JSON, I actually get a nice user interface that's generated from the configuration in the registry. So I can see that it has a package argument of -- transport, which is standard IO, and that's not something I can edit. And then I can see it has this ES iOS API key for authentication. That's called --API key. It's required. It's also a secret. I can see this little I here. So if I type stuff in here, you're not going to be able to see it. And I can see that when I haven't filled in the required fields, I get a warning. But as soon as I have filled them in, the warning goes away. And you can also see that it's going to build the MCP server configuration as I fill this user interface in. So as a user, I'm basically just going to come in here, and your client will do the same thing. Your client will run a similar interface based on the metadata to say like, oh, I need to collect this field. Here's some attributes about it. And then once I've collected that field, I can generate the MCP server configuration. So in the real world, the user is going to come in, see an interface sort of like this, maybe a little bit prettier, collect the information they need, and they're not even going to be exposed to this MCP servers at all. The client's just going to say like, great, got the information I need. I can generate an MCP server config for that and run it. So it's getting a lot less geeky and a lot more user-friendly by having this metadata that allows us to configure the clients in that way. So some important notes for publishers and for clients. So every server from the registry is available as a server.json object that complies with a schema. It includes metadata with publisher info, repository information, information about the packages, which are the installable MCP servers, and the remotes, which are the hosted MCP servers that are hosted on the internet you can connect to. And the server object can provide detailed configuration information for the packages and remotes, such that a client can generate a custom config UX. And this is sort of the big point I'm trying to make in this whole video, which is by carefully crafting the server.json, you can enable clients to create custom interfaces and configure your servers, ensuring a great user experience and a valid server configuration. So you can create very specific, correct user interfaces that are going to give users guardrails, let them point and click, and when they're done, that should generate a valid configuration. The values should all be within their respective ranges. The required values will all be present, all those sorts of things. And I'm going to give you some examples of what you can do to kind of help make that happen. So overview what we're going to talk about. So first of all, there's a very good documentation page, this generic server.json in the open source repo that gives you lots of examples of much more complicated than I'm going to give you today, sort of all in one. I'm just going to take little snippets and show you how to do individual pieces, but these docs are very good. So I definitely refer to those. So we'll talk about package and remote configurations. All of those configurations are driven by this thing called an input element. So those are arguments, which can be positional or named, their environment variables, and their headers. And we'll talk about the key concepts, and I'll give you a quick example in JSON and in the user experience of each of the key concepts, which should go pretty quick. So packages are installable servers. These are servers that we're going to install and run on our local machine and then connect to from our local machine. So they include a repository, a transport. Oftentimes these are going to be standard I/O. They're just standard I/O MCP servers you run on your local machine, but they can also be SSC or streamable. So you can run them on your local machine, but connect to them over these HTTP protocols. There's good reasons why you might want to do that. And we have things like a runtime hint to tell the client how to run the server. We have runtime arguments and package arguments, which are the arguments that are passed in the traditional MCP configuration for standard I/O. And we have environment variables. And then for remotes, which are hosted servers, so these are MCP servers that exist on the internet or not on your local machine, we'll have a transport type, we'll have a URI to connect to, and then we'll have headers. So that's the basic configuration that you're going to be able to define for either a package or a remote. All of those configurations are sort of built on this core concept of an input, which is something that the user is going to input typically. It'll include a description that's going to be displayed in the user interface, whether it's required, whether it's secret, a format, which can be string, number, Boolean, or file path, a value. The value property is a fixed value. So some people inadvertently use this as like a default value. If you put a value in there, that means that is the value of that parameter. So it can be used for a fixed value, or it can be used for a template. And I'll talk about how templates work in a second, but essentially a template can have elements within the template that can be replaced by other inputs. And there's a couple of very common use cases for that. You can give it a default value, you can give it a set of choices. So let's say you want to constrain a string input to one or two particular values, you can do that. And then you can also have variables that sit underneath an input, which are essentially sort of another sub input that fills in a template. That'll make more sense when I show you a demo. So arguments also have a type, which is either positional or named. So positional being just it's in this position in the argument list, and named being usually it has a -- name in front of it, and whether the argument can be repeated. And for named arguments, environment variables, and headers, they also have a name. So there's sort of a name along with the rest of the configuration spec. So a very common use case for remotes is to have an authorization header that takes a bearer token. And I'll show you how to do that using this new configuration specification. So we're going to use token substitution with variables. So here we have a header that's named authorization. This is the description the user is going to see in the UX. This is the value. So this is a fixed value that'll be bearer space and then API key and braces. And then we have this variables as part of this. And underneath variables, we have defined API key, this guy right here. And it has a description that the user will also see, whether it's required. In this case, it is required and it's secret. So instead of just saying this has a default, that's bearer space, type your key here, we're actually building a structured input that's going to collect the key and stick it into this header formatted properly. So let's see what that looks like. We have a test server here that implements that. So if we go to configure that, the user interface you're going to see is something like this, where you'll see, hey, I have a header that's authorization, that's bearer API key, and there's a variable that's my agent API key that's required that I have to type in. And right now I don't have anything, I just have this API key. But if I type something in here, and you can see that's also secret, so I can type some garbage in here, and it will actually construct the authorization header properly formatted with the stuff that I typed in there. Right, I can turn that on and off. So this is super simple. A lot of people don't get this right on the first try, but this is how you want to build an authorization header, and this is how variable substitution works in general. There's lots of cases where you have sort of, maybe you have like a key value where the key and the value are both variables that sit underneath of some other header. So you want to specify the format of that, but you want to allow the user to type in the things that are going to build it up. So pretty straightforward. That's probably our number one use case. Probably half the servers in the entire registry are going to use this or should use this. So let's go to a different example of a package that we're going to install locally that has a bunch of arguments. So we're going to show you how you use fixed, positional, named, and repeated arguments. So we'll go through just quickly what this looks like in the spec. So we have a description that says this is the required server subcommand, it's positional, and its value is MCP. So this is a fixed argument that's at the first position that can't be edited by the user that has this value. Pretty straightforward. Then we have a directory allowed to host file system operations. This is a named argument. Its name is -- allowed dir, and it's is repeated as true, which means this can occur 0 or more times, as many times as you want. And then we have another one called debug mode that's named with its -- debug. It's required, its format is Boolean, and its default is false. So let's see what that would look like. So that's this package right here. And again, you can see we have an arg that's MCP that I can't edit. We have an allowed directory, so I can do path foo. And because it's repeatable, I can add another one. So I can add another path, and then I can also remove that. So I can have as many of these as I want. And then I have this required debug mode, which is defaulted to false. And because it's a typed value, I can set it to true or false, just with a drop down there. And then that's it. And then as I do that, you can see it's building out the server configuration. So again, this is what a client's going to see in a user experience. This is what they're going to have to type in, and they're generally not going to be exposed to this part. So let's go back to the next example. So let's give you an example of an environment variable. In this case, we're going to use a string format, but we're going to give some choices. So we're going to say, I want to set the log level, but I want it to be one of these 3 values. And again, we see a lot of servers that could be using this that aren't, that sometimes in their description, they'll say like, set it to debug warn or info, but it's very easy to actually just force that set of choices with this choices value. So let's see what that looks like. It's actually in the same one. So I have my log level environment variable, doesn't have a value set, but I can set it to any of these 3 values. And when I do that, you can see that it gets filled in there. So this is a much nicer experience than type a string and hope it's correct and read the description of what to type in here. If you have the ability to use choices, if you have the ability to use Boolean types, numbers, or choices, you should definitely do that to constrain what the user can do and help them, sort of help guide them into easily being able to build the correct configuration. And then let's look at one more that's a little more complicated. So this is URL templating with a required numeric argument. And this is a little bit of a different case because you're going to say we have a transport that's SSE, and it has a URL that's running on localhost at some port that's defined by a variable and its endpoint is SSE. And then we have the package arguments that define this port variable. That's a numeric required with a default of 8089. So this case, the variable resolution is a little bit different. So instead of using a variable that's defined under here, this transport is going to actually take these tokens and resolve them against package arguments, runtime arguments, or environment variables. So essentially anything defined in the package that has the same name will get substituted here. And the reason we want to do that is because we basically want to say, I'm going to use this to determine how to run the server. So I need to define the port to know how to run the server. And I want to use that same port to determine how to connect to the server. So let's see what that looks like. So that's this package here. And so we're going to say our configuration is going to be very simple. It's just going to take the port, and it's 8089. And it's going to generate two pieces of configuration. It's going to generate an MCP server configuration, which is how we connect to the server. And it's going to generate a runner configuration, which is how we run the server. And in both cases, it's going to use this 8089. And if I change that to 8080, it changes it in both places. So pretty straightforward, but this is super nice because this means instead of kind of hard coding this value to some fixed port that the user may not actually choose, we're able to allow the user to configure the port that they run it on in the runner configuration and then use the same configuration in the transport configuration. And again, the idea is in a sort of properly constructed client, you're never going to see that. At most, you're just going to see this port, and this is all just going to sort of be magic. But this substitution is another kind of clever thing, and it's something that I think in virtually all cases of packages with transports that are SSC or streamable that have a port, you should do this. Because it's almost always going to be wrong if you don't specify the port, because the user is going to run it on a port and you're going to have a fixed value here that isn't going to be right. So anyway, there's another pretty simple example. Okay, so let's do one other thing. We built as part of this registry a test mode for server authors to be able to test their server.json. So that's actually what I've been using to do some of this demonstration, and I'll give you kind of an example of how that works. But you can take your server.json, paste it into this page, and then you can both validate the server, running it through schema validation and a linter that we built to identify sort of common errors that you might want to fix. And then you can also test the server just exactly like I've been showing in this demo. So let's go back here. So this is kind of what it looks like. When you come into this /tester URI, you're going to see this header, and you're going to have an empty edit control. You can just paste your server.json right in here. And you can do two things. You can validate it. So I don't have any validation issues, and you can also test it, and that takes you right into this user interface. So if you want to see like, hey, I have some server.json, I built some configuration, I'm not exactly sure what the client's going to render, how it's going to look, and if it's going to generate the right MCP server configuration, you can just paste it in here and hit validate, hit configure, hit test, and see what it's going to look like. And oftentimes when you do that, you're going to see things that aren't exactly the way you thought they ought to be, and it will give you some inspiration to go back, make a couple tweaks, and fix it. And I'll give you kind of a quick example of how to do that in 1 second. So the first thing I'll show you is that the validator does catch some things. So let's say we got rid of the headers because we just didn't like the headers in there. And let's say we go down and we make this type something odd. And then let's get rid of the URI for this. So now this is an invalid configuration in a bunch of ways, and we hit validate. So now we're going to get some errors and some warnings. So it's going to show us, oh, hey, this type is supposed to be one of string, number, Boolean, or file path, but you type Booleans, which is not right. That package transport doesn't have a URI property, which is not correct, and the remote doesn't have any headers. This is only a warning because you might have a remote that doesn't have any headers. That's not usually the case. They almost always do. But you might have a remote that doesn't have any headers, so we give you a warning. And you can get rid of things like that by, for example, if you wanted to make that warning go away, you can be explicit about it and say, hey, I don't have any headers. And now that warning will go away. So this is just sort of a way that we can see, yeah, we have some issues that we might want to deal with. And a lot of times these warnings and the linter warnings, which I'll give you a big list of those. There's like a whole bunch of things that we check for that are a lot of sort of style things, but oftentimes they do point to configurations that need a little bit of work. You might have something like, you might have an environment variable that has the name secret in it, but you haven't indicated that it's secret in the configuration. So we might say like, hey, that's probably not what you intended. You probably wanted for that to be secret. So there's a whole bunch of things like that where we try to give you some guidance. But once it's all said and done, you can hit test configuration. And I'll give you an example of how that might work. So this is a server that I kind of like. It's got a pretty sophisticated, nicely defined configuration. So let's look at what that looks like. So this is this Florentine AI server. It's an MPX server, takes this static runtime argument of pointing to the package. I'd sort of question this because it's fixed on latest and you might not want to run latest. So this might be something you want to configure. We tend to like to pull the current version number and put it in there instead, but whatever, that's fine. It's up to the MCP server author what they want to do there. So they have a package argument, the mode to run the MCP server in static or dynamic, but we can see that's not something we can edit. That is set to static. So that's probably not correct. And then we have a bunch of other things. So we can see, do you want logging, true or false? I can set a path. I can see I have this token that's required. So I can type something in for that. And then a bunch of other optional values. And I can see it generates a nice, configuration. But let's say, okay, I'm not really thrilled with the fact. I think this is a mistake. I think this is supposed to be a variable that lets me pick between static or dynamic. So what would I do about that? So I'm going to cancel out of editing. I'm going to go get the server.json for that. So I'm going to copy that to the clipboard. So the other thing you can do is you can inspect the server.json of any server. So if you see like another server that you like the way it does something and you want to look at the JSON, you can go do that. And let me go now into the editing mode. So I'm going to paste that server.json for that Florentine server into here. First we'll validate it. So it gives us a couple of things. So it tells us this runtime argument, the first runtime argument has a value, but it also says is required. And the second one has a value that says is required, the package argument. So if we look at that, and that actually kind of is going to give us a little bit of a hint to what the issue is. So this one is a fixed value. So there's no reason to put is required here because it's just a fixed value that it's always going to be present. And this is the one that we talked about before. So this is also a fixed value. And it says is required. So it's like, I wonder what they intended. If they put is required, that sort of implies that they intended for the user to be able to edit the value, but the value is also is this word static. So I think what they really wanted to do was probably this. They probably wanted to make the default static. And then just for extra credit, where you can say choices, I can spell. Okay, so we can add, so we change the default to static and the choices to static or dynamic, and then we can just go back and test it and say like, okay, let's see, is this what we wanted? And now I can see I have this required mode. This is static or dynamic, and I can click down and I can click static or dynamic, and it's like, great. If that's what I wanted, then I'm done. I now have a new updated server.json that I can stick into my configuration. So that's just not to pick on the server. I actually like this one. I think it's pretty good, but just to give you an example of, I can take my server configuration, paste it in here, play with the user interface. If I see things that don't look like they render quite right, or the configuration that's generated isn't quite right, I can go edit it, tweak it, revalidate it, retest it, and when I'm done, I have a completed server. So I think this is just a nice tool to help people build good user interfaces and to understand like how this configuration language, which can be a little bit complicated, actually ends up being implemented on screen in the user experience. So I guess in conclusion, I think everybody should be preparing for the official registry and the other registries that are going to use that schema and that API. I think this is going to be the way that we find servers, whether it's through that actual official registry itself or whether it's through something that implements that. So on the client side, I think you should prepare to discover your servers via that registry API, which is pretty straightforward. And you should be prepared to configure the servers via the server.json configuration. So the examples I've sort of given above, right? That's how you should be thinking about how you're going to configure MCP servers. And for server publishers, I think the real focus is you should be putting your servers into the official registry, and you should really focus on creating high quality server.json configurations and validating them so that when end users through their clients find those servers, they're going to have a great point and click experience that's going to be very rich, and that's going to give them the exact correct configuration that they can just run the server magically, and nobody's going to have to look at MCP servers.json files ever again. That's the dream. Anyway, I think it's really exciting work. The team working on this in open source has been super dedicated and done a lot of great work. And I think it's going to be the way that we find and configure MCP servers going forward. Thanks.